Hello. So before I get started, I made a mistake in the last video. I removed the GNU source define in the make file, and then it seemed like it still compiled after I did that. And this GNU source was in order to allow me to use ASPrintf, and it turned out that this made it no longer compile, but I didn't notice it because the make file was just reusing the previous version of the compiled object file, and so I thought that my build was still working, but it was not. So so as an addendum to the last video, I have to point out that I undid my attempt to clean up the macro use of this macro, and I just kept it in the util.c file here, which I think makes plenty of sense because if I put it in the make file, it's just going to apply to all of the source files. But if it only applies to this file, then it's more explicit about where the non-standard usage is. So yes. So what do we want to do this time? I think that we're going to need to change binary search macro. So the binary search macro, if it returns if it doesn't find what the binary search was looking for, then it sets this what was it? Was it E? It sets E to null, and there's no way to know where, like in the array, it would have been if you had to insert it. And so what I want to do is I want to mimic the Java standard library and actually return a index that indicates where it should have been inserted. And in Java, what happens is I forget the name of the API, but you can have it search so the binary search will return an index, and if the index is negative, then that means you just have to find the complement of every bit, or just do a bitwise not operation, and then it will tell you the index where the item should have been inserted. Now, the reason why we need this is because we need to, in the case of the user inputs like two characters which don't have a match. In other words, they don't correspond to any code, even the prefix of any code, then we need to figure that out. And so what we're going to do is we're going to do binary search in the key map, which is sorted lexicographically, and in that case we need to so in order to know that there's no like kxy or kxz, we need to be able to look around in the map array for items that like have this this kind of this as a prefix, but be kx as a prefix, but not kx as the actual code. So in order to do that, we're going to have binary search tell where the actual search ended. And so this reminds me of something else we need to do. I need to revisit this decision we made. Revisit code sorting. So if we look at makemap.h, I think, no, we look at, what was it, mapping.h. We have a code CMP function which compares codes, and this compares based on the length first before it compares the actual value. So code CMP here. So what I think I'd like to do is just try something where we here, and we're going to add this to every line there. Okay, now we're going to just try returning stir CMP. Oh, it's right there. Just try returning stir CMP and see if the tests all pass, and I kind of think that they will. Nope. So what actually failed? Default mapping, make map, default mapping. Okay. So let's do the diff and see. We may not want to update this test. Okay. So it removed quite a lot. And so I don't quite remember why we wanted to do this. Oh, the reason why is because it's no longer sorting in the same order, the codes, and so it looks it looks very different. But really, probably all the codes are the same, just in a different order. So let's do this. Let's take each file. We have these two files. We're going to copy this. So we have these two. We're going to take one, sort this first one into temp A, and then sort the other one, sort mapping test out, into temp B, and do diff of A and B. And they're the same. So yeah, perhaps we never really needed to do that, to do this sorting by length first. That may have just been a bad idea. So, but there must have been a, yeah, I guess the reason why we did this is so that we can, now that I think about this, we did it so that we can look inside of the code mapping array, I believe, in order to find codes that started with some prefix, but without seeing other codes interspersed in between them. And I think that does not make any sense. I think that may be a bad justification. So the idea was that if we're looking for kx, and there's actually kx, A to Z as codes, then we wanted to be able to search for kxa, and then just iterate down the list of codes, and that way we wouldn't have to worry about kxab being there. But the thing is, kxab should not be a code if kxa is a code. So this may be a poor justification. So, or wait, so maybe the idea is maybe kx, we're searching for kx, and kxa is a code. So kx and kxa is a code, and also kxbb is a code, and kxc is a code. And maybe actually this is more complicated, like b to z is a code. So we don't want to, if we're basically looking for A and C because these are potential codes that complete this prefix, but we don't want to have to worry about KXB, B to Z. And so, yeah, now that I think about it, this is probably why we, so I think it was a good reason is to sort by length first. So I think we're going to keep this. I'm glad I remembered that. Yeah, I'm wondering how much I want to explain about this, but okay, let's undo what we just did here. Okay. Now, so that means we're stuck with this sorting order, so the reason why we're thinking about this is because we want to be able to search for instance, kx. Imagine that kx, or like we're searching for kx, and actually, kx A to Z is not a code. So no code actually starts with kx. So I guess but we also want to know that kx A to Z with 2 is not a code, right? So I think that we can do that. But I'm starting to feel like, so that means that we're going to have to search for kx, \001 \0, and then kx 001 001 in the code array, and see if anything is in that vicinity in order to know that kx is not the prefix of any code. But then again, we don't really need to figure it out early. So maybe it's okay that the user types kx and then is allowed to continue the code even though it's never going to potentially end with anything. But okay. So I think that it's going to be easier if we sort by if we do sort without considering the length, and just consider strict CMP, which of course considers the length, but kind of as less important than what the actual characters are in the array. Because sure, when we complete the when we look for codes that start with a prefix for with just one character after it, that does mean that we're going to have to kind of jump around a little bit in the array, but that's not really all that bad. That's not as complicated as searching for KX001 and KX and like kind of like searching for all of these. So there's two things though, like so I think I just mentioned both. So concerns. So one is that how hard is it to determine if a code starts with a given prefix. And so in this case, if we use code CMP as it is now, this is kind of hard. But if we use strlen, this is easy. And then the other is how, let's just determine. So the other concern is we are looking for all codes that have a prefix with one more character. And if we use code CMP, this is easy and fast. But if we use strlen, it's either slow or complex. Because if we do it efficiently here, we're going to have to search. Whenever we see something that is not the right length, we're going to have to do a binary search to find out where we want to, like where the length is restored to what we actually care about. So the other concern is what was it? It was there was one other thing I was thinking of. What was it? Okay, I had to pause for a second there off screen and think for a little bit. So yes, the other concern is when considering all codes that start with a prefix but have two or more chars in it after the prefix. This is if we want to say like kind of give the user a summary of what they can type if they type two more characters. So with this, it seems to me like it may be easy. So code compare. This means we kind of have to add in these two like padding characters 0, 1, 0, 1 and do a search, and then we kind of loop through those. But I think so yeah, then we're not going to have the shorter codes interspersed, but I think that that doesn't really necessarily mean it's easier. It may be okay to have the shorter codes interspersed because we still need to show we still need to show the keyboard as it is, right? We still need to show the keyboard as if you can just press one more key, or we also have to show kind of guides when the key may have two more characters in it. And so in that case, interspersing the length is probably just as natural as not doing it. So I think for 3, we can go either way. All right. So I think that so there's really no good reason to choose code CMP exactly. There's no real good reason to choose strlen either. So for 3, I kind of think that Sterling is a little bit easier, or at least a little bit more natural. So yeah, it's going to be hard for me to make a good decision here. I think that we'll just keep code CMP as it is, and because I don't really see any reason to keep it either way. I mean, to keep it or change it, so I'm just going to prefer the status quo. Okay, revisit code sorting. So let's keep code CMP. And now we want to refactor binary search because we want to, which I like what I just explained, we want to be able to tell if any code starts with a given code, if any code starts with a given prefix. So, so yeah, this is going to be interesting. So right now, binary search kind of communicates to the caller of the macro by means of the pointers into the array. And so that means it does need to take EL, which is like the array itself. But I think it's more flexible and maybe even easier to use if instead we don't even care about EL. We care about instead we just have the user care about like manage the actual array. And so in here we're not going to set E, right? We're just going to set the index. So E is actually going to be I now, and EL is not going to be needed, and we're just going to have the user worry about dereferencing things in the array. And actually, let's get an idea for how many times we use binary search. We use it a lot. We use it a lot, so I don't know if maybe we want to create a new one so that the caller can decide which one they want to use. So maybe like binary search as the index using indexes will be the more primitive one, which some may want to use. Yeah, I don't know. So let's rewrite. Let's pretend that we have to rewrite one of the uses, like check kanji DB order using the proposed new API, which will be like this: index. So it'll be I count and then compare. So we do. Let's call this index. So here, we're going to do a binary search, and instead of SI, we're going to have like S size T, sort index, sort info, SI, check order. So what is sort info? I know maybe I should just do this mechanically. SI index. I want to also like understand what I'm doing as I change it. So binary search. Let's call it index and take SI index and sort infos.count, and this will be stir CMP. And the thing we're searching for, or the thing that we're thinking about, is SI or sort infos dot el, SI index dot C, and oopsie, and then K I dash C, K, because K is not going to change at all. All right, and then down here we would do if SI index, let's see, is less than 0. That means it failed. And after that we would say SI sort info. then we would do si equals sort infos.l plus si index. So yeah, this is a little bit roundabout now. This has gotten a little bit more complex. So you just have to check si, and over here. So BSearch is nicer, I guess, because it automatically assumes that all you want is the like thing you end up with. It assumes that all you want is the element in the array, and you don't really care about the index, and that might be fine for most uses. So let's keep both APIs, and what I'll do is let me just undo the changes in check kanji DB order, right? And I'll reload it. And so, okay, BSearch index. So index or mid. So we don't no longer need mid, I think. I think we just need index. So we'll just do index equals this, and we don't need to set e here. And so index. Okay. So this kind of works at this point, but the thing is, we don't really know the end result if it is like correct or not. So we probably want to have a int CMP res. Oh, we do CMP res here. All right, we'll have it there, and down here, if this is interesting. We don't stop early if CMP res is 0. Oh yes, we do. We do right here. Okay. Now if CMP res is 0, then that means we found a match. But if it's not, then so if it's greater than 0, that means that it needs to go after. Let's see. That means that the thing that was proposed was too high. So the index is equal. If we want to insert a new item, it should be right in this place in the array, because that means it'll go before the thing we just compared it to, and the thing we just compared it to is greater than it based on CMP res. So else if CMP res is less than 0, then we do index equals not. So in this case, the thing we just compared it to is too high. So we have like the thing we just compared it to is too low. So that means we're going to have to put it after this item. So not index plus 1. Okay. Now the problem with index, I think, is that we technically need to put it in parentheses because it may be it may be like a dereferenced pointer or something like that. So let's see, do we have any other usage of this? Okay, so let's just do a find and replace. So index replace index replace with index in parentheses. Okay. Index. Okay. Okay, good. So if comp res, then we break. So I think the compiler should be smart enough to know that it just needs to skip these 4 lines. If it breaks out of this while loop, and then it knows that none of these should be true. And anyway, this is not going to take a long time to run through anyway. So I don't think I need to micro optimize this by any stretch of the imagination. So now we want to fix BSearch itself. Let's or define it rather in terms of BSearch index. So we're going to do size t index, and we'll do BSearch index, and there's index, count, and compare. Oh, is it possible to define it in terms of BSearch index? I don't think it is, because that means the comparator. Oh, but we can set L equal correctly, can't we? No, because this is basically an inline thing, CMP. So it looks like, yeah. Well, it can have a super low level BSearch, which can even handle both of them. So BSearch index is fine as it is, but we need an even low level like BSearch, which is BSearch like internal or something, and this will take a index and a count and like a comparison prelude, and then the comparison operation itself. All right, and while. So, okay. Now, BSearch internal is, so this is going to be like BSearch index, but it's going to do a little bit more. So before CMP, we need to do a CMP prelude. CMP prelude. Now, I guess we do want to have a semicolon there. Now BSearch internal. Okay, BSearch index. So BSearch index does not need a prelude for BSearch internal. So we'll just do BSearch internal index count comparator prelude and comparator. All right. And maybe we don't need this wrapper here. Yeah. Yes. Now BSearch is going to have a prelude of setting the index equal to, or no, setting element equal to no, element is the array, so E equals L index, and then the comparator is this. Okay. And so down here, if index is less than 0, then that means it failed, so we can do E equals 0, or null, rather. Okay. Now this looks like it should work. Must have some syntax error somewhere. Wow, that's a lot. While min is not equal to max. Okay, here. Forgot a backslash. I forgot a lot of backslashes, actually. Okay, and over here. Okay. Let's go to the top. Did I forget something else? Why are there so many errors? Let's see. Trying to find the prompt. Where did I actually start screwing up? Here's the prompt. If CMP res less than 0, CMP res is less than 0, while res, okay, if or, okay. What happened here? Why is this not working? Oh, I forgot there. Let's try that again. Okay, 125. Using past 4 arguments, but just takes BSearch index. Okay, check kanji DB order. BSearch index. Did I call? Okay, BSearch index or BSearch internal. Now let's just say we don't really need this internal one. I don't think I like this internal one. I'll just have it use bsearch index be the internal one. Internal. Bsearch internal. Okay. Dex. Okay. That way they can just pass an empty argument for the prelude thing. Bsearch index. Bsearch index. Oh, where is it? How is it implicit? Bsearch internal. Oh. Bsearch index. Okay. Let's try again. And incompatible types when assigning to type struct. All right. Okay. Got to do this. Plus that. Okay. Good. Now, I think we may want to test for bsearch index because it's a little bit complex. So let's add a new test. Right? It is called bsearch test. And we're going to go ahead and go into bsearch test.c, include util.h, and test util int main void. And we'll do a start test case, start test, the file, and index found item. Okay, and end test expected content in file. No, we don't need to store it in a separate file. This is going to be simple. End test. So what does end test actually take? Test til.h expected output. Okay. So let's see here. We're going to do a bsearch index, and we give it a index value. So it's t index and element, the count rather. Count is 5, and we'll give it like, let's see, int. We want to have an array to search, right? So int array equals. Okay, I was interrupted there for a while, and so we're writing this test, and we're going to write a simple test for our binary search algorithm, and we bsearch index, and so those are the things array we're searching through, and we are going to go into here element, so index count prelude, we don't need anything. And for CMP, we will compare array index minus 15, and then we should get 2 back because that's the index. So let's see here. We want to do xf printf out %d and index. I guess we actually want LLD and end test, and we expect 2. So make out. All right, we need commands .h for the definition of out. LD, no, just one L. Okay, that worked. So if we change it, let's make sure that fails. Yes, it does. Okay. So found item. So we can add a space here maybe, and then let's try it again with like other values. So we also want to try it with 20 and 5 for the lowest one. 5. Change word. So this now the result should be 0, 2, and 3. 0, 2, 3. And it didn't work. 5, 15, 20. No new line. 0, 2, negative 6. 0, 1, 2, 3. Index. Okay. 20. Oh, the size is not 5, it's 4. So let's add 17 here to make it 5. No, that didn't work. So it is 5, right? And we're comparing this. This is looking for 5, this is looking for 15, this is looking for 20. Okay. 0, 2, 3 and 0, 2, 4. All right. Yeah. This should be 4. And okay. Now we'll have to do another test for not finding something. File. Index did not find. All right. So let's copy this. We're going to base it off of what we just did. All right. Now imagine we have let's say we find something that's less than the lowest element in the array. Actually, let's do this. We can do size t size equals size of array divided by size of array. Okay. So we don't have to repeat ourselves here. This is size. Okay. Now here we do 0 minus 1. So just so it's more intuitive. So that means it should be less than 5. So we should find it in the bottom. It should be inserted at the first element in the array. So that means index should be. We're gonna do not index, not index, not index. Okay, size and size. And here we'll do 24. So this would mean it should be at the end, which means it should be equal to 5. 5, 0, and 15 is fine. Let's say 16. In that case, the place where insert should be where 15 is, 0, 1, 2. So 0, okay. And we already have 2 there. So now we can make this. No, it didn't work. No new line, 0, 3, 5. Okay, so 16. I made a mistake. It should be right here. So it actually should be 3, not 2. All right. So yes, the test showed a mistake in my thinking. And there was a bug in the test expected output. So, okay. This seems fine to me for now. So I think we can commit this. Submit BSEARCH binary BSEARCH index implementation. Okay. Now, why we did this in the first place, it's to make input test work correctly so that we could enter in impossible code, and we enter in like a K and then capital J. That should not find anything. So impossible code, let's try that. Okay. Let's, okay, we want to actually just copy this and show it. Okay, so this should reset the keyboard. So this should be the same as this. So how are we going to make that happen? We need to go into input.c, and is done needs to check if the code can possibly be finished based on that prefix. So here we say if we find something, that means that we do need to end at that point. Otherwise, what we can do is we can create another code. So this is extended input. So extended input equals so far input. Okay, now does that work? Return set but not used. Assignment to expression with array type. Okay, yeah, that didn't. So we got to do memcopy, I guess, and that is extended input. All right, size of orig t. Okay. Great. So now what? Now we need to figure out the length of, so we got size t orig length equals sterling of so far input. Right. Okay. Orig length. Or orig is confusing because there are two orig t's. So this could be so far length. So far length. So far. Okay. Oh wait. Size of. Okay, that's great. So so let's see here. So now what we need to do is we're going to do a BSEARCH index of or here for so or while. Okay, we know that we need to do this at least once, right? So while so far lang plus is less than size of so far input minus 1. Okay, so we're going to add we're going to make this extended input longer and longer. Extended input so far len equals 1. And so then that means we're extending the length by 1, right? And I guess we can just increment it here. So so then we do a BSEARCH index. Oops. There. And we're looking for size t. So what should we call this? We're looking for this in this kind of impossible code, extended input, in the mapping. So extended I, and we'll do BSEARCH index extended I, and then the length, which is mapping dash cnt. What was it called? Mapping.h codes dash codes dot count. And then comparator is code cmp of let's see, extended I mapping dash codes dot l and it is extended I. Yes, okay. And we're comparing that to what we're looking for, which is extended input. All right. Okay. And that seems fine. So if extended input is less than lang, extended I is less than mapping dash codes dot count, and the item that extended I is greater. The item that this points to should have the same prefix of so far input for this to actually be valid. So we're going to do stir and compare, and this is the two strings and then size is last. Okay, so mapping dash codes extended I and dot orig actually is what we want. Dot orig. So we don't need to reference or take the address of that array. Orig, and then we're comparing that with so far input, and the length is so far len. Oh, we need to reuse the original length of so far input. So okay, so this is so far len. Okay, so that means for size t tried len equals so far len, then it's not length, it's more like the character index that we're trying. Tried len plus 1, tried len is less than size of so far input, or let's just orig t. And then, not comma, but semicolon. And then we do tried len plus plus. Now here we return 0 because that means we've tried every length and it didn't work. So let's move this over here. And we say if extended, so now we do if extended I is greater than or equal to 0, that's a bug. Bug should not have found code in map, because we check that because these are creating impossible codes, right? Which where we use ASCII value 1 as one of the characters in the code. That should not work in any circumstance. So now we do extended I equals not extended I. Okay, now we can actually use it. So if it is greater than or equal to mapping codes.count, then we continue. Okay. Now if not stir CMP, maybe to make this more consistent, so far lang. So we will use continue here as well. Then down here we use return 1. All right. So far input, so far. Okay. And that may just be what we are looking for. So we're trying to see if orig and so far input have matching prefixes. And if not, then we continue, we're not using it. And otherwise we return 1 because there's a match there. So let's see how this works. Okay. So this is saying if trying to see if we're done. So actually, if there's a matching key, then that means we're not done. A matching key. So matching prefix code exists. Not done. Inputting. And this is matching prefix code does not exist. Done inputting current code. Right. But do we really want to stop it anyway? Do we want to stop it and then make the user not able to enter anymore? Maybe it's more like what we're going to do is we're going to show some kind of an indicator saying, hey, there's no valid code that starts with this. And then the user will have to press backspace. But for now, yeah, I think I kind of like that better. So we'll do something like static int is code prefix, and we're going to have the same arguments in here, right? Okay, and this is where we actually use all this stuff. Here is code prefix, and then we can actually use the more intuitive values for this. All right. So we're going to distinguish between is done and has a matching code prefix. Because if we don't have a code to the matching prefix, that means the user ought to be able to press backspace and kind of try again. But they should still be told that they don't have any code that can possibly start with this prefix. So so far then. So here we're going to need this over here. And we're going to use this down here. Extended input is used up here instead, not down there. And here we continue to return not M like we did before. Okay. So now we can say if it's done, then we such and such. Now if not is code prefix mapping and so far input. Do we want to take the address of so far input? That doesn't make any sense. So far input orig t. I guess I don't see well enough to know if I need to if I want to pass an address of orig t or not. I guess I kind of do. Orig t. I guess I want to pass an address of. I don't want to pass the whole array literally. So, if it's not code prefix, then fprintf or xf put s. We're going to have a little error, like invalid prefix out. Okay. Okay, I was interrupted for a second. Now we set it to out. Let's make that. See what happens. Okay. So far input. All right, 13. So far input. Aha. So it worked down here, but not up there. To take the Sterling of something. That's confusing. Perhaps a parameter of spec const cover arguments of type const char. Okay. So I guess we need to dereference it at that point. All right. But does it make sense to use orig t here? I guess it's more like we want to use a const or char const. Orig t. So far input. Not quite sure what I want to do. 25. Extended input. Extended I. Extended input. Oh, didn't pass enough arguments. Okay. So there, pass another argument. Didn't work. Oh, I passed the extra argument to the wrong thing. Okay. Now, subscript is neither array pointer nor vector. So 34 here. Orig. Okay. Mapping dash codes. So which subscripted value, mapping dash codes, codes, oh, dot L is what we want. That's a really easy mistake to make. Invalid pointer type, so far input. Okay, did this problem again. So actually want to dereference so far input. And Sterling from incompatible pointer type. So 50 for input, so far input. Okay. Okay, so this may not be the right size of thing. I guess it is actually. Size of orig_t. Okay. Let's see what was wrong. Cat. Okay, good. Looks like that worked. So we essentially are alerting the user that that it's so far input invalid prefix. Oh wait, I don't see invalid prefix. If not is code prefix. If is done. Is done. It's not what I expected. Prefix, let's see if it actually gets here. Okay. Oops. Invalid prefix. Oh wait, it is printing invalid prefix. Did I cat the wrong file last time? Yeah, I catted expected test out. That's why. Okay. Okay, I confused myself. So we want to make this a new line, I guess. Okay, let's try this again. Cat. Invalid prefix. If is done. If not is code prefix. Well, that doesn't make sense. Invalid prefix. It prints invalid prefix at what point? It's after it writes the keyboard, prints a backslash, then it gets a key, and it adds it to Sterling to the so far input, and then it's going to see if it's done, and it's not going to be done. Then it's checking if it's a code prefix, and apparently it's coming up as no. So tried len is this tried lang. Oh, I didn't actually use the right lang here. Okay. Tried lang. Maybe call it trilen. Tried len. Trilen. Okay. So far lang len. Okay. Maybe that's enough to make it work. So to test out. Cat. Invalid prefix for the first one, but not the next one. Extended input. Okay. Triling. Triling. So size of. Now we don't want to try the longest length, right? We don't want to try equal to size of, because that's not going to work. But yeah, we do want, I guess this is right. We want to try up to one less than the size of so far len. Okay. So extended I. So yeah, I don't think invalid prefix should not be here. It should be down here. So is code prefix. Matching prefix exists. Okay. Change to matching prefix code does not exist. So invalid prefix. Okay. So let's read this code and see what we're doing wrong. So we're setting extended I. We're using that to search, and we're searching in code CNT. We're trying to see if we have something that matches extended input. And of course, we're not going to have anything that matches extended input because it's an impossible code. So we compare it to that, and so if extended I is more than count, then then we have a problem. Or if it's equal to count, then we have a problem. Or it can't. That means that there's no code greater than it, which means that there's no valid wait. There's no code greater than it. So we should input it at the end, which means there's no code greater than it, which means there's no code that comes after this. There's no code that has this prefix because this should be the lowest possible character, ASCII code 1. So extended I, and then we compare the orig and so far len. Oh, do we want to compare so far len? Yes, we do. So far input, so far len. And we're comparing where we should have input it, where we should have sorted it to that. So that looks correct. Continue. And if we have that, let's continue. That means we don't have a match. But otherwise, we do have a match and we return 1. So let's see. Extended input. Try len. Oh, here we go. We actually want to start at so far len itself. Try len, or we want to. Yes, this is confusing. So is it length or is it index that we're writing to? And I guess what I wanted to do was make it the length. So that seemed to be a little bit less confusing. But I think that it's less confusing if there's less math to do. So try I guess. Try I. All right. And we don't want to try writing into the last index because that is the null terminator. So we -1 from there. Okay, this should be what we wanted. Try len. Try I. Okay. Impossible code. Okay, good. So the first test is not what's broken anymore. Possible code. Invalid prefix. Invalid prefix. And then it prints out the empty keyboard. And that's good. That's what we want. We're basically saying, hey, there's nothing you can type that starts with that. And by the way, even if you type more characters, you won't have a valid code. Or even if you type 2 or more characters, you won't have a valid code because there's an invalid. You have an invalid prefix there. So, are there any codes that are 4 characters long? Because basically, I want to make sure that invalid prefix does not show if we can type 2 characters but not just 1. In other words, let me find examples so I can make this more clear to myself. So I think there's some really long romaji ones. There's 3 characters here. XX7. No, I guess they're all 3 or less or fewer characters. So there's no codes that are 4 long yet, which means that we can't really test anything. Can't really test the logic for more. Okay. So this is kind of like unnecessary. It has some unnecessary complexity, I guess, but it's going to come in handy later. So, I mean, we could try creating a bogus mapping, which doesn't really exist, and that would kind of allow us to try some crazy stuff. Input. Yeah, I think that might be a good idea. So we're gonna create another test, input test, which considers the fact that we might want to try longer and longer codes. So we'll have a test where we type in 1 character, and we type in 1 character, and there's no matching code prefix with just 2 characters, but there is with 3. And that actually, we already have that. Now that I say it out loud, we do have that, because we don't need 4, we just need 3. And so we have DYO. By the way, what is the orig size? Orig size is 4, so we only support 3 character codes anyway. Okay, so if we type in X, oh, there is XA already. So is there 3? So KW. Yeah, actually, maybe we do need to make that bogus test. X W. Because I really do. Oh yeah. Okay. Yeah, this is going to get to be more involved than I originally thought. But essentially, we need to start a new module which has the input implementation, but is not the actual is not like the input command itself. And the input command will do some very simple stuff to call out to input implementation. I can't just put the implementation in input.c itself, because that would be inconsistent with what we did with all the other commands, where like the command and the module that backs that, with the logic that backs up that command, are in different files. So we're going to have to create a input implementation file. Shared objects implementation. Okay. Input implementation, and we have now an input. Do we have an input.h? What are we doing with input.h? No, we don't have an input.h. Okay, make file input.h. We need to actually get rid of that then. Let's see here. So we're going to have to start splitting up. We're going to create a new kind of change which splits up split out input into implementation module. And the funny thing about that, well, we didn't actually do that yet. So what we just did is we did an implementation of the invalid code thing. So so this commit message is not really right. So maybe we just want to do in the same commit where we split input out into a separate module, and we do the invalid prefix check. But in any case, commit 3 has input.h, and there is no such thing as input.h. Okay, so let's remove this input.h and add all GCM nest fixup equals h3. Okay, so get rebase I. Okay, so now we no longer added that bogus header file that we don't really need. So we are going to do what at this point? We're going to, yeah, let's just put all this in one commit. So we're going to add input implementation.i, input implementation.h rather, and edit input implementation.h, and here we're going to do int input implementation, and this will take a mapping as well as a, well, really all it's going to do is take a mapping for now. So so struct mapping. Okay, and where is mapping? It's in mapping.h, I guess. Yes, we just checked it earlier for a different reason. Then we're going to rename input.c to git move input.c to input impl.c. Actually, I guess we'll just copy. Git. I didn't know it's not a command. Input.c input impl.c. Now we're going to fix input.c to just do only what it needs to. Pound include input implementation.h, right? And no, I guess. All right. Okay. So input now is going to be simpler. We're going to say it's just going to it's going to create a mapping. It's going to don't need so far input here anymore. It's going to populate the mapping, and then it's going to say return input implementation. Do we ever return zero? We non-zero? We don't return non-zero yet. Well, let's just allow it to return non-zero just for later. Input implementation, address of mapping, and then mapping.destroy. Oh, int or res equals int res, and then we do mapping destroy, and we return res. Okay. Input. Now we don't need any of this stuff at all. Oopsie. That's not what I meant. Delete it. It's done. Okay. But we do need the mapping stuff, and we need input implementation, but no standard library stuff, I think. Mapping, input implementation, mapping. Okay. Then we open input implementation.c. Let's yank this first. Edit input implementation.c. Okay. All right. Struct mapping input so far. All right, mapping destroy. Okay. So recipe commences before first target. It's interesting. Oh, I probably didn't add a backslash somewhere here. Okay. Input. Okay, 63. From incomplete pointer type. Oh, okay. Mapping. Don't need to dereference. Don't need to take the address of mapping anymore. All right. 76 is done. Is done. These should all be const maps. Const. Right. Is code prefix. All right. Impossible code. All right. I think this is just the same input that we had, the same expected test output we had before. Okay, good. So then we need to edit input test and do this, add this like weird code. So possible code requires 2 more chars. All right, and we're going to say x, but the code is xxx, or x, maybe the code is xyz. Okay. Then main input test. Okay. And mapping. Oh, we need to add a mapping, but mapping is not. There's no such. How do we even declare mapping here? Put implementation. So we're going to pass the mapping, but how do we create the mapping if it doesn't actually exist yet? Maybe we can do like mapping type, enum map type. And one is, do we really want to do a enum? Because I don't really like enums that much. Ergonomic sort requires XYZ, has XYZ code. Okay, has XYZ. Okay, and here we do enum mapping type, ergonomic sort. Here is has XYZ. Okay. So we need to actually initialize the mapping now. So struct mapping equals that. And then we're going to do mapping destroy. Just a mapping. Then we have to include mapping.h. And then we'll have a static void populate mapping. Mapping set, I guess, or set mapping. And then struct mapping, set mapping. And then enum mapping type. All right, switch to M. Switch to type. And case ergonomic sort, and we'll do a mapping populate. How does that actually work? Input.c mapping address mapping, and mapping.ergonomic sort equals 1. Otherwise, we're going to do case has XYZ, and this is like a manual kind of a one. And otherwise, we do bug unknown mapping type. Okay. So mapping edit mapping.h. We have key array codes, edit mapping. So it's in nullmoji.h. We want to populate the codes. So we have a mapping, or how about grow? What was it? Grow array by, and we pass it mapping dot codes grow by 1. Then we say mapping dot codes dot element 0 dot L, or we already dereferenced L dot orig stir CPY setting it to XYZ, and the result is this, or let's put a Japanese character here. All right, XYZ, and oh, silly me. Stir copy mapping dot codes dot L 0 dot convert to that. Okay. All right, now I think we're ready. Okay. So it should not consider this an invalid code. But if we type in X something other than Y, then it should be like X X or X X bang X exclamation mark. All right, mapping undeclared 29. Oh yeah, okay. Change E M dash. Here we do M dash codes. Okay, let's try again. Implementation. Okay, input test needs to include include input implementation.h. Okay, and here we actually we need to initialize the mapping, and that would be done by doing set mapping, and set it to the type of what is the test case. So that would be test cases test I dot mapping type. Test implementation. Okay. Too few arguments. That means we have to pass mapping. Declared here. Okay. All right. Good. Possible code. So this is fine. Let's just do the copy command to make this the new test output. And then we'll run the next test. And okay, invalid prefix. Okay, so that's kind of what I wanted, basically. So if we type X only, then we're not going to say it's an invalid prefix. But if we type because we can still type XYZ, but if the user goes and types X something else besides Y, then we do say it's an invalid prefix at that point. So let's amend this, and we'll say this is that's one of the things we do. We split out the input, but we also say warn user on invalid prefix. Okay. And this is kind of a big commit at this point, but it's probably a pretty good point to stop. Yeah, I'm pretty happy about where we've stopped now. So we're warning the user when they've typed a prefix code which is not conceivably going to end in a valid code. But we don't actually go and delete what the user already typed, because that would be that could be wrong. That seems a bit rude. We instead want to do something else, like give the user a chance to backspace, or give the user a chance to type the characters in and have them be literally entered and not converted at all. So maybe we can just look at this commit one more time. Oh, let's review BSEARCH. So binary search, we added a new binary search which you can use to figure out where the item should have been inserted, and if the item is not found. And we also added, we split up input command into an implementation and the input command module itself. And in the input implementation, we have all the logic, and we also allow passing an exact mapping rather than just generating the mapping ourselves. And so that's pretty good. I think that we're ready to stop. So next time I'm actually going to want to set the input to raw mode, or standard input to raw mode, and see if that allows us to use the new sort input more intelligently. Oh, I should probably make sure this works. So it's like A and invalid prefix. Why is it saying invalid prefix? Press enter. Yeah, it says so. Enter thinks it's invalid. Now if I do Control D, that's the end of the file. That worked. And so like KJ enter. Okay, enter and enter. Okay, so it just cleared out the code because we typed too much. So if I type this, that's considered a valid code. Now I can do something like type 4 and see what characters start with 4. So that's pretty cool. I can type 2 and see what characters start with 2. Oh, it didn't work because of the enter key. So these are all the characters that start with code 2, or the key 2. And I can do 3. These are all the kanji whose codes start with the number 3. I can also do slash. These are ones that start with slash. And so that's kind of fun to do. And so you get to see like all the kanji that show up close to each other in the in our sorting order. So this means /1 would be fish, sakana here, and head or neck would be /5 apparently, and barley would be /6. And that all makes sense. Taberu or eat is very common character. That would be /f. And then dai or subject is /d. And kaze or wind is /s. And those are all very easy to type, so I like that. And tori or bird is /j, it looks like. So that means tori is not considered very common, since it uses the same hand as the slash character, or the key that comes right before it. So that's a little surprising, but I guess everything on the left side is very common, so that makes sense. So anyway, I think that we're done for today, so thank you for watching.